Hello everyone and welcome. In this video I'm going to talk about linked lists. This is a very important data structure, and in this video I'm hoping to teach you how and why you should use them, how to insert, delete, and search elements inside of your linked list, and more. So let's get right into it. First of all, why would you use a linked list? Well, up until now, if you wanted to store collections of data or lists of data, you would probably create a vector, right? And this is okay if you're fine with having your data statically allocated and if you know exactly how many elements you want to store in your list. However, if you don't know exactly how many elements you want to store, you would either create a super large array from the get-go, and then the space that you didn't take up would just go to waste. Or if you were adding elements to your vector and you reached its maximum capacity, you would reallocate a larger vector, copy the contents from the previous vector, and keep adding elements, right? Well, you can probably tell why this is not the most efficient way to do this, and that's where linked lists come in. So a linked list is basically a collection of elements which are linked by pointers. So each element in a linked list is going to contain two parts. One is going to be the actual value or the contents of that element, and the other is going to be a pointer that's pointing at the next element in the list. And then the next element is going to have the same thing, right? And then maybe this is the last element, so this is going to point to null, and there we have our linked list. And the first element here is going to have a pointer called head, which is going to be the beginning of the list, right? The head of the list. And this is much better than the options I was talking about before, right? Instead of allocating statically a contiguous block of memory for your vector, you're just going to dynamically on the heap allocate exactly as much memory as you need for each individual element in the list, right? And they can be scattered around your memory. They don't need to be contiguous. So maybe one element is here, maybe one element is here, maybe another one is here. And the most important thing is how you link them together through pointers and not so much where they are located, right? And another great upside is inserting and deleting, especially in the middle of the list, which is something that you can't easily do with a vector, right? So if you want to add an element between these two elements, what do? Well, you allocate memory for that new element, and then you grab its next pointer and you point it at the element that's going to be after it, and then you grab here the pointer of the previous element and you point it at the new element. And there you have it. You've successfully inserted an element to the middle of the list, right? Now you want to delete an element, for example, from the front of the list. Easy peasy. You grab the head, you point it at the second element, and then you delete the first element here. And boom, you've successfully deleted an element from the front of the list really easily, right? Now this does have one downside, which is the search operation. If you want to search for a certain element, you need to do a linear search. There's really no other way. You need to go check each element one by one to see if that element is the element that you want, right? And that's how you search in a linked list. Now, enough with the explanation. I actually want to show you some code because I know that's what you want to see right now. So for this part, I'm going to be using C++. I am going to assume that you're comfortable with the basics of this language. However, it's not going to be something super hard to follow along. So let's get right into it. First of all, each element in our linked list is going to be something called a node. And a node is represented by a struct. So let's type struct here. Let's call this node. And this is going to represent each element of my list. Inside of here, we're going to have two things. We're going to have the actual value of the element, which for simplicity's sake, I'm going to make an integer. And then this is going to be a self-referencing structure, meaning inside of the structure, we're going to have a pointer to another element of the same data type, of this same structure. So we're actually going to have here a node pointer called next. And this is going to point to the next element in our list. So let's actually create our list here. I'm going to call this head. It is going to be a node pointer, and I'm going to allocate this on the heap using new. So I'm going to say new node here, and there we have it. We have the head of our list. Now I'm going to say head value is going to be, for example, 10, and then the head next, since we don't have any more elements, is just going to be null, right? So now we have our list created here, and notice that this is only a representation. So it's not like a vector that you actually look at it and you can see that it is a collection of elements. We're only going to have here a pointer that's going to represent the beginning of our list, and that's going to be our head. Now let's actually create here a function in order to print this list so that we can actually check out what elements we have. This is going to take in our head. And in here, I'm going to teach you how to iterate through the linked list. So in order to do that, I'm going to create here another pointer, which is going to be called current. There's going to be a copy of my head, and now let's actually iterate. So I'm going to say while our current is different than null. So basically, while we haven't reached the end of the list, then I'm going to say that the current equals current next. So I'm basically going to go to the next element of my list. But before that, I need to actually print that element. So I'm going to see out my current value. And let's just get here a separator. And there we go. This is how you iterate through a list. Now let's actually come here. Let's say, oops, not this. Let's say print list like so, and pass in our head here. And let me run this. And this is hopefully going to return to us our list, which only has one element for now, which is 10. But let's take care of that now. So I'm probably going to be doing this a lot, right? Because for each element, I'm going to allocate specific memory. So I'm actually going to copy this and delete this. And I'm going to create here a function that's going to automate this for me. So I'm going to say node, which is going to be returned by this function, create new node. I'm going to pass in here the value I want to create the node with. And I'm going to paste this right here. Now, instead of calling this head, I'm going to call this new node. And I'm basically going to do the same thing, but instead of 10, I'm going to say that the value is going to be the value that I pass in. And then all I need to do is return the new node, like so. So down here, I'm going to say node head is equal to create new node with the element 10. And there you have it. Now, if I run this, it's going to output the exact same thing. Now let's actually add a couple of elements to my list. So I'm going to create here a function. This is going to return to us a node pointer, and it's going to be called add to start. This is going to take in our head. This needs to be a pointer like so. And in here, I'm going to add an element to the start, right? And I'm also going to pass in the value of the new element. So how do I do this? Well, first of all, I'm going to create a node here, which is going to equal create new node. Oops, I need to give it a name first. So let's say new node is equal to create new node with the value that we pass in. So now we have our node, and now let's actually add this to the beginning. But before, I need to make sure that my list is not empty, right? So let me say if my head is equal to null, then I'm going to say that the head is equal to my new node, right? Because the new node is actually going to be the new head of my list since we don't have anything there yet. And otherwise, I'm going to add this to the beginning. So I'm going to first say new node next is going to be my head. So the next element after my new node is going to be the current head. And then the head is now going to be the new node, right? So the head is actually going to change. And now all I need to do is return the head, right? And now let me come down here, and I'm going to say that the head is equal to add to start. And I'm going to add, for example, 20. And if I run this, oops, I've forgotten to pass in the head as well in here. Now let's actually run this and see if it works. And there we have it. We've added an element successfully to the beginning of the list. Now let's do this one more time. Let's add to start. Let's pass in here the head, and let's add, for example, 30. And if I run this, we've successfully added 30 to the beginning of the list, right? So easy peasy. Now let's learn how to add an element to the end of the list. So I'm going to create here a new function. This is going to be a void. I'm going to call this add to end. And in here, I'm actually going to pass in a double pointer to head in a value. Why am I passing in a double pointer? Well, that's because instead of returning the new head like I did in the previous function and altering from outside of the function, I actually want to alter the list directly from inside of my function. I don't want to have to do that outside. So for that reason, I'm going to pass in here a double pointer. And then we're going to need to iterate. So as always, let's create here a current copy of my head like so. And this is double R. And we also need to create our new node. So let's say new node is equal to create new node with the value like so. And always check if your list is empty first. So let's say if head is equal to null, meaning our list is empty, then my head is going to be my new node, right? And with this, I've actually successfully altered the head from it within our function, right? Because instead of setting the head equal to the return of this function, I've passed in a double pointer, and I've said that the contents of that pointer are going to be the new node, right? And then otherwise, we're going to iterate. So I'm going to say while current next is different from null, then current is equal to current next, like so. And notice that I'm not going until current is equal to null, right? I'm only going until current next is equal to null, because I don't actually want to go to the end of the list, to the part of the list where it is actually null. I only want to go until the last element itself, so that in the end I can say current next, like this, is equal to the new node. And hopefully this is going to work. Let me go down here, and I'm going to say add to end. And I'm going to add, for example, 20 here to end, actually 25, so that I have a different element here. And if I run this, let's see what happened here. Oh, of course, I forgot to pass in here the reference to my head. I always forget to do that. So let's run this again. And hopefully now we've added 25 to the end of the list, and we have, right? So let's do this again with another element. For example, 32, something random. And if I run this, now 32 is at the end of my list. Now, probably for the most important part of the whole video, I'm going to teach you how to add an element to the middle of my list. I'm going to use this same approach of altering the list from within my function instead of doing it from the outside. So in order to do that, I'm going to create here a void, let's say add to middle. And this is going to take in a double pointer head, like that. It's going to take in the value of the element after which we want to add the new element and the new value of the new element, right? So like always, we're going to have to create here our new node like this. And this is going to be create new node, and we're going to pass in here the new value like so. And we're also going to iterate. So we need here a current, which is going to be a copy of my head, and I forgot here the equal sign, and there you go. Now, as always, we need to check if our list is empty. So if head is equal to null, then we're going to set the head be the new node, and there we have it. And otherwise, we're going to have to iterate, right? So I'm going to say while our current next is different from null, then current is equal to current next, like that. However, we can't just check if the current next is equal to null. We also have to check if the current value is different from the value that we pass in here, right? Because we are looking for a specific element, right? And once we're done with this, we actually have a couple of options, right? So either we found here the ending of our list, so current next is equal to null. However, we haven't found our element, so current.value is different from our value. Then in this case, this means that the value we were looking for is not inside of our list. So in that case, I'm going to see out element not found and a \n, like that, right? Now, otherwise, if we have reached the end of the list and we found the element that we're looking for, so if this happens, then this is basically the case where we need to add the element to the end, right? So all we need to do is say current next is equal to new node, like that. And otherwise, this means that we found the element we were looking for and it is in the middle of the list, right? So how do we do this? Well, let me actually pull up my whiteboard here. So if we actually analyze here the case where we want to add an element to the middle of the list, for example, we want to add a new element right there, we can't just take the pointer of this element and point it here to the new element, right? Because then this part of the list is just going to be lost. We're going to have a memory leak because we don't really have anything pointing at that piece of the linked list anymore, right? So we don't really know where it is. So let me actually delete this, not the pointers. And before we actually do this, we need to point the next pointer of the new element to the next element, and then we can point this to the new element, right? So if I actually go here to my code again, so what do we have to do? First, we have to say that the new node next is going to be the current next, so the next element after current, and then we can say that the current next is equal to new node, right? So first we link the element that's after current to the new node, and then we link current to the new node. And that is all we need for our add to middle function. Hopefully this is going to work. Let me say here, add not to end to middle, like that. And we're going to pass in here the reference to our head. The value can be, for example, 10, that's right in the middle. And then the new value is going to be, for example, 23. And now let's actually run this to see if it works. And there you go. Now 23 is after 10 here. Now let's actually add this to the end of the list to see if our function is covering all the cases. And there you go. And now let's add it after an element that doesn't exist, for example, 90. And if I run this is going to give me element not found, and then the list is going to be intact. Perfect. So that is our add to middle function. Now let's learn to actually remove an element from my list. And I'm actually going to do this with only one function. Instead of having a function to remove from the beginning, the middle, and then the end, I'm going to cover all of the cases in one go. So let's get into it. So for this function, I'm actually going to make this return a node pointer, which is going to be the new head. Let's call this remove. This is going to take in our current head and the value of the element we want to remove. So first of all, let's make our copies. Let's say current is equal to head. And we actually need a pref pointer, which is going to point to the previous element. I'm going to explain better what that means exactly. And now we're going to have a couple of cases. Always check if your list is empty. So if our head is null, we're just going to return null because we don't have anything. Otherwise, if our head value is equal to the value of the element we're looking for, then that means that we're looking at the element that we want to remove. Now, how are we going to do this? Well, first of all, we're going to say that the head, or rather, we're going to say that current, which is the copy of our head, is going to be our head next. So it's going to be the value after our head. And then we need to delete our head, right? So we need to basically free the memory that we allocated for our head because we're not going to need it anymore. And we're just going to return current, which is going to be the new head of our list, right? So that's how you remove an element from the beginning. Now, otherwise, we're going to iterate it. So I'm going to say while current next is different from null, and we haven't reached the value that we want. So current value is different from the value we're looking for. Then we're going to set the current to be current next. So we're going to keep going in our list. However, we're also going to store the previous element. So I'm going to say pref equals current. So we're going to store current and we're going to move on to the next element. You're going to see why this is important. Now, when we're done iterating, we're going to have a couple of cases. So if our current next is equal to null, so if we've reached the end of the list, however, if our value is not the value that we want, then that means that we've reached the end of the list and we haven't found the value that we want. So we're just going to return head, right? We're not going to remove anything. We're just going to return the head, which remains unchanged. Else if the current next is equal to null. So if we've reached the end of our list, but the value that we actually wanted to reach is there, so we have the element that we wanted at the end of the list, then we're going to do a couple of things. We're going to say that the pref next, like that, is going to be equal to null. So the element before the last element is going to point to null, and then we need to delete current, right? So we're going to basically free up the memory that current took up, right? And otherwise, then that means that the element that we want to remove is at the middle of our list. So what we're going to do, well, we're going to say that the prev next, like this, is equal to current next, like so. And we're going to delete current, right? So we're actually going to link the previous element to the element after it. And then we're going to free the memory corresponding to current, right? Let me actually open here my whiteboard. So if you have here a list with a couple of elements and you want to remove this element right here, you need to take the pointer from the previous element and point it at the next element. And then you need to remove that element, right? So that's exactly what I did. I took the previous element, I've made its pointer point at the element after the one I want to remove, and then I've deleted the one I want to remove, right? And then all I need to do is return the head that remains unchanged, right? And this is how you remove an element from any position in your list. Now let's actually see how this works. Guys, I apologize, but I've actually made a typo here. This is not one equal sign, this is two equal signs. And now this should work because it wasn't working before. So let me say remove here head, and let's remove, for example, 30, which is the first element in our list. And if I run this, there you go. So now it's working. We've removed the first element of our list. Let's remove 32, which is the last one, to check all of the cases. There you go, 32 is gone. Let's remove now 10, which is exactly in the middle. And there you go, 10 is now gone. And just for the sake of it, let's remove 25 to make sure I haven't made any more mistakes. And there you go, now 25 is gone. So I apologize for the typo there, but that is basically all I wanted to show you today. Thank you so much for watching. If this video was helpful and valuable to you, if you really understood how and why to use linked lists and all of the functions that I've implemented, I would kindly ask you to like and subscribe to support the channel, and I'll see you in the next video.